So I recently started a new project last night, and it is what you see here. It's just got a basic map scrolling, some ground units, a whole bunch of shots, and bad guys, and movement, and little animations happening, and it's obviously inspired by something else. I'll talk about that today, but I want to show kind of a high level how I put this together in a day, and we're not going to go line by line through the code, but I want to talk through the steps that I did to transform something that was a really easy starting point, layer by layer, into the kind of thing that you see here, which again, of course, this is not done. This is the foundation we're going to build on with a team, but had to get a prototype in place. So first of all, several years ago, I was still doing some speed coding demonstrations, and one of those was how in about 75 lines of code, you could put together a really primitive space shooter, right? And so it only takes maybe 10 minutes to do, but I'd already spent those 10 minutes, so I built on the code I'd already written, went to my paste bin in the description. Over there on the YouTube, you'll see leads to that in the raw text. Click the raw text, copy-pasted this into a new file, and that was the foundation I was able to build on. Now, my target for this was that when I grew up as a little kid, we rented a game for Nintendo Entertainment System called Legendary Wings. And gosh, if it wasn't really neat. I didn't get very far. I wasn't very good at it. I don't actually know a lot about the game. But it had this flying dude, and he shot stuff, and it was a shmup, and a vertical scroller, and there's canyons and water, and that's about as far as I'm getting. There's power-ups. Ooh, wait, also, you'll see in a second, there's some targets on the ground, these little metal turret things. He drops bombs on them. I thought that was a real neat mechanic in combination with it. Obviously, other games have done that, but those are things I wanted to capture the gist of in my prototype. So for stage one, we got this behavior you see on the left where I can use the arrows to jump my ship around. I can press spacebar to fire. I can targets can bump into me and reset me, or I can hit the targets. If I look over at the code, it is verbatim, just straight up copy pasted off of my little YouTube speed hackiness, complete with 2-letter variable names, short for player X and Y, and enemy and shot. And we got a little array we're packing things into. There's an update loop that's doing all of the drawing, all the update loops, all the collision stuff, and just straight up key codes for the inputs. My first step was making this a little bit easier to work with. I replaced some of the hard-coded constants with some nice variable names, replaced the 2-letter variable names with nice spelled-out words. I also, in the process, changed the game, so instead of being side-scrolling, it was vertical scrolling, which you see here. Additionally, I changed the resolution to be Nintendo Entertainment Systems, which is 256 by 240. For the next stage, I stretched that little NES-sized resolution canvas up to a 4:3 resolution. This is actually 800 by 600, using a pretty straightforward trick. I say straightforward, there's a couple little catches. But the gist is that we're actually drawing to a tiny little canvas that's not seen on screen. The canvas that's on the web page, we then as a final draw step, stretch the small invisible canvas onto our target canvas. This allows our graphics to operate at that resolution while scaling up. Now you might notice that now the elements are rectangular, and of course this is not maybe ideal by modern standards, but it was kind of the basic way that graphics looked on the NES, where our pixels were stretched a little bit side to side, because the resolution was not quite matching the 4:3 of our televisions at the time. As a minor catch, we do go out of our way to turn off some of the scaling smoothing. By default, it'll try to blur the edges, and even though old televisions were pretty blurry, this is actually kind of a look that today, even for retro remake stuff, it tends to be easier on the eyes. My next stage didn't actually change anything about the functionality. Instead, I just broke up the code into multiple files, one for input, one for main, one for enemy, one for player, one for shot. Even without a class structure in place, just making it easier for me to arrange the information as it started to grow, that I could target my changes to certain files in the project, and then using HTML file in the middle just to import those. For this next change, I'm going to show before and after, because it's a little bit hard to see from someone else playing. But before, when I'd push the keys, I'd have to tap the arrows. You might even be able to hear that key being pressed. And I have to tap to fire. And of course, that's not very smooth. It doesn't feel very good. And so in the new approach, in addition to adding some more shots to it, I made it so you could hold down the key and move at a constant rate. So you can see I hold left, let go of left. I'm holding down spacebar to fire, rapid fire. And for the comparison, in the old input code, it immediately, when you pressed space in a key push event, pushed into the list or changed the variable position for the character. In the new approach instead, and this is the same way I teach in one of my Udemy courses, I just have a function that updates false or true to some bool values. Am I holding left? Am I holding fire? And then over in the player logic, while the key is being held in the update call, that's when we slide or that's when we fire. In this case, again, we're stacking 3 different elements. Partly I wanted to test and make sure that we weren't going to need major collision optimization since we have lots of shots and lots of targets. I thought it'd be fine at this resolution, but I wanted to get that tested sooner rather than later in case I had to rethink my collision system. So for the next version, I wanted the shots to spread out. So before they went up in parallel, and now they're forked a little bit, since like a lot of these old shmups, I want to have a variety of power-ups that'll cause the shots to increase in spread or increase in number, and not only affect more targets that are straight north of the player. You'll also see that now when I move, they don't quite bunch up in front of me as bad. They still do, but they kind of move with me, and I can even sort of stand back and throw my weight side to side to get a little more of a wave pattern or wider spread. And the way I achieved that was twofold. First of all, I changed where I spawn elements to additionally indicate a horizontal and vertical velocity. These numbers are, I think, about sine, cosine of 5 degrees or so, which later on I'll probably use a degree value, but for now, just look those up real quick. And then I have partial momentum being applied, so a different momentum is being applied vertically or horizontally, and vertically it's different if I'm driving up than down. These numbers are basically fudge factors I experimented to figure out what multiplier felt right. If you leave them exactly at 100%, it's pretty severe. And then I just updated the shot code, so every single frame, instead of adding a consistent step as a shot speed going north, I read the value on that respective bullet in its update cycle. For the next part, I added some graphics. For this, I made some simple sprite strips. Here you can see the player. The gray here is actually going to be transparent. It's just the browser is displaying it as if there's a background behind it building up. And then for the bugs, which I've decided the back edges are based and inspired by characters from Legendary Wings, you'll see it as have kind of their legs wiggling, and I got some eyeballs that are yellow to help them stand out. Then I also added some wave behavior and decided to use a ocean blue for the background fill. And you can start to see it's kind of taking shape as we have our character flapping wings and the bugs moving. You'll also notice in the corner I have some text being displayed at a much higher resolution than the characters. Let me show how those different pieces are put together. For drawing the animation frame, I made a simple function where I pass it which frame to use as a multiplier. It's using the width of the frame as a skip value to skip over 1 or 2 frames, and then those are all cycling over in my main logic. I set up a separate interval to run at a different frame rate to determine when to actually animate those sprites. And what I'm doing there is calling a function on the different bodies, in this case the player and on the enemies, incrementing those frames so they're all animating in sync, but at a much different frame rate than the movement. If the animation's cycled here at the same speed as the motion's being processed, those wings would be way too fast and the bugs would just be kind of a blur of their legs wiggling. If we look at some example of how that code's being drawn for the bad guys, where it's drawing them, we call them with the name of their graphic, their X and Y position, the frame, and their dimensions, as some constants defined at the top. And if we look at how that function is written for loading the graphics, it's also partly inspired, mostly based on code from my second course, where when the program starts, instead of immediately initializing from our start code, we first call load images. Load images has a stack of elements to load. Each one that loads counts off how many have been loaded once the last one's loaded. Calls a function called loading done so start game. That then kicks off the timers to make the gameplay happen and the enemies to spawn. The enemy movements here in these sine waves are just being done by using a bit of math on having a wave size per character and using some offset phasing, some offset frequencies, some randomized values with minimum maximum tuning up top, but it's playing around to make them not just go straight down, but look a little bit more like they're hard to dodge, or for that matter, might attack you from the side, giving you a reason to dodge to and fro. Okay, so the new element we added for this stage is the scrolling back on better rows. In the previous one, I forgot to mention the sharper text. All I'm doing to do that is after I stretch my small invisible canvas onto my scaled canvas, I can then just draw the text directly to the after scaled actual visible canvas. That allows me to have sharper text, which in this case I'm just using for debug values to keep straight how many elements on the screen. Since I added a little bit of code, so if an enemy leaves the screen, it's removing it from the array so it doesn't grow indefinitely. Shots are no longer going far off the screen, enemies no longer piling up off the screen. Eventually we might move to a pooling model, but so far there's no performance problems, so we won't sweat it yet. As far as how the scrolling's being handled, it's really pretty straightforward. Right, we have one number, which is how many pixels it's scrolled. We have a rate for how much to scroll it per frame. In our update tick, we are adding that value to it at a consistent basis, and we look at how it's being drawn. In our draw background function, instead of using an ocean color flood fill, we are taking the height of the image minus the height of our screen, so that's why we have a negative of the amount. We're offsetting it by that number that's counting up, and the reason why I'm computing that into a separate variable is to then say, well, if that's going to be scrolled past the top of our visible play area, well, then it just stops scrolling. And so it caps it at 0. And that's then we're drawing the image looked up by that string from our string load into that. And this is literally just a tall image for our background. So when we author these, we can use arbitrary graphics. We can use a 3D render. We can do all kinds of other details. We can custom paint elements and shadows and other elements that we care about. And of course, because this game is magnified in terms of using this blown up stretched pixel effect, we can actually get quite a bit of detail or a pretty long level without having to worry about how many pixels we're tying up with full screen information of detailed backgrounds. And then for our final stage, just 2 quick changes. One, now we have some animations for the shot set up in the same way as the animations from before. In this case, I actually have all the shots stay in sync. They use a single shared animation frame between them. I just think it's a slick effect versus if they were randomized or in some other kind of cycle. I like that look. Now, another thing you'll also see is we now have ground targets that stay in their position on the ground, just like you saw in the game. I don't yet have bombs attached to be able to attack them. I think I actually have a key hooked up that just does a quick debug log. That'll happen later in development. But now we can actually place elements on the ground to attack, shoot from the ground, drop bombs on, and so on. Now this is something there is a little bit of code redundancy. It is currently actually separated out as a split different list. It looks like some parallel code, and the whole separate array. Even though they could theoretically be combined in the same array, this is actually sort of a mild optimization simplification, because the ground targets, I don't need to do collision against all of these constant bullets I'm going to be streaming out into the air, and vice versa. There's a bunch of different things that do and don't affect when they get drawn in the order, right? Ground stuff's always going to get drawn first. Let me show this as my main, because it's pretty straightforward. Right, we always draw our background, and then our surface enemies, and then our player, and then our shots, and then our enemies, and that just makes sure that our layering is real straightforward, and not having to do some sort of constant rearranging of data in memory to make sure that they're drawn in a good order. Those lists are being kept separate at this time. But aside from that, that's the state of this project. As a prototype, I'll be pitching with to the team. Obviously, several factors or systems might get refactored, might get updated, might get rethought, might get scrapped entirely, depending on how we move forward. But it's just, it's a visualization of the concept. We might not even keep a winged player character. For me, that was just sort of a fun way to start out because I really liked that first 25, 30 seconds as a kid of that level. And again, I never really got very far in the game. I think we just rented it, never even owned it. But that is the start. And of course, for a prototype, the real function is to get a sense for the players of what's going on, to show the other developers on the team we're going to collaborate with what kind of game are we talking about. And I also really wanted to go for here, you'll see I'm streaming tons of enemies, and that's because what I want to go for is a little bit more bullet hell with lots of moving elements, lots of targets, lots of shots, and I'm kind of curious to play with the idea of stacking up power-ups and how those will play against a horde of bad guys, where can we really balance the game so you can become massively overpowered with 5, 6, 7 different shots coming out in different directions and homing shots and all kinds of other advantages and spinning defensive things around you, and at the same time tune the enemies against that so it's still engaging, still challenging, still of interest. But that's the gist. We'll be developing this over the next several months in Home Team. If you want to build games with us, check it out, hometeamgamedev.com.